Hello students, here we are going to learn about ILP formulations. So different integer linear programming formulations have been proposed for the routing and wavelength assignment problem. So in WDM optical network. So the synthesis for this mathematical model for a symmetric system or symmetrical system with a unified and the simplified notation for widely use of the different objectives. So asymmetrical traffic model that all the formulations, both the link and the path formulations. So WDM wavelength division multiplexing and DWDM dense wavelength division multiplexing networks correspond to wavelength routing network. So where the network ensures communication through the light path. So a light path is an optical end-to-end connections carried over a wavelength on each intermediate link along the route from the source to the destination node. So now two light paths going through the same fiber can share the same wavelength. So this is so-called class constraint. So the particular set connection request or set of variable wavelength. So routing and wavelength assignment RWA problems aims at the defining the set of light path so as to accommodate all or most of the connections while optimizing a given objective particular functions. So next the variables. So the set of variable that will be used in the classical ILP formulations for RWA problems. So here we consider as one or two set of variable over here. So first is x of k. So consider here as the two value 1 and 0. So if 1, then if the connection of k particular k is accepted, so at that time 1 or all other case, so like then the otherwise the value consider as a 0. Same as x raised to lambda. So again the two value is represent over 1 and 0. If the wavelength lambda is used, so at that time the value is 1 in all case. So write down the otherwise the value is 0. So therefore particular reason, so we consider the four different objective functions over here. First is minimize the blocking rate. So it is equivalently the minimize the number of acceptance connections. So this objective is most relevant when there is not enough transport capacity, like is enough available wavelength or to accommodate all the connection requests. So at that time these are the not enough transport capacity. Second is minimize the number of used wavelength. So it is usually assumed in that case that the all connections can be established given the available wavelength and the objective is use the smallest number of them. So to determine the minimum number of wavelength using binary search, so a fixed number of wavelength and the solve the particular RWA problem. So with the objective of the minimizing the maximized number of wavelength on a fiber link in the particular network. So third function is minimize the congestion. So this third objective is concerned about the minimize congestion. So that is expressed to the minimize of the maximum number of wavelength to the particular fiber link, so that for the less number of route can be converted into the more number of route, so the less number of bandwidth is occupied and the less number of data, so less congestion. Last one is minimize the network load. So consider for that there is enough wavelength so that we can accept all the kind of requests from the various connections. So even if the fiber link can each support up to consider as a W wavelength, So it is not always necessary to light on the all them. So in which case, in the particular case, some electronic equipment can be saved the particular node. So this last objective, the particular deals with the network load defined as the ratio of used wavelength over the all over potential of the number of wavelengths. So they define the network load particular network in the optical scenario.